I am Joel Hallas, the technical editor of QST. I thought I was not going to be that as of 2 days ago. I was scheduled to retire on December 31st, but I let myself be talked into staying another 3 months because they haven't found a replacement yet. So there's a job opening up there if anybody is interested in letting me escape from this. So I guess I thought that I'd be available on Thursdays to do this sort of thing and told Fred, but actually I woke up in Newington today, so I left a little early and came down to do it. I guess I'm a member of GNARC also, and live in Westport, and I have a sailboat with a HF mobile rig on it. It's been at QST. In fact, it was on the cover of QST in July of 2009, 2010, something like that. So we've been a ham for 55 years or something. So I've done a lot of stuff. My background is as an electrical engineer. I worked for many companies in many industries. This is actually my 5th career, depending on how you count. And one of the previous ones, I had the pleasure of working with Paul Danzer at Norden when I first moved back down to Connecticut in 1980. So that was nice. I have a connection to Sarah a little bit, even though I've never been a member. W1ZR Alan McCracken was the person who gave me my novice and technician exams back in the mid-50s. And was also our family's lawyer, so that we got to know him pretty well. Anyway, I'm going to talk about something that is certainly not a new invention by any stretch because it's been around since the 30s, but it hasn't gotten a lot of attention in the amateur community, perhaps until I fell over it a couple of years ago. And I've done a number of articles about it, as you may know, but I thought I'd like to introduce the topic to you because it's kind of this title, Another Approach to Multiband Antennas, relates to another presentation I may have given here some years ago about different ways to do multiband antennas, and I didn't cover this one. And this is called sleeve-coupled antenna elements. And what that means, let me see if I can figure out how to work this. If I do that, nothing. Okay, what happens if I do that? Something like that. No. Okay. There are more charts than this.
Space bar. Down arrow will usually work.
Well, I'm trying down arrow and I'm not getting anywhere.
Page down.
I could get the mouse out. I could, what about that? There we go. Okay. Most antenna discussions start with the lowly half-wave dipole, which is kind of the basic elemental antenna element, if you will. Approximately a half-wave length long at your at whatever frequency you're using it on. I say FL here because I'm going to have another solution for the next higher frequency. There's some kind of a transmission line and some kind of a generator of RF that drives it. So this is fairly straightforward. But it's interesting that the sleeve concept is the following. If you take that half-wave dipole at one frequency, and you take a tube, metallic tube, and slide it over the antenna, and that tube is some shorter length that's resonant at some higher frequency, we'll call it FH, half-wave length long, and you make a hole in the middle of it so you can connect your feed line to the inner one. Notice the feed line is just connected to the inner half-wave dipole. The sleeve is just sitting there, not doing nothing. It's not connected to anything. It's just insulated from the antenna. And if you do that, all of a sudden, you have an antenna that operates on both frequencies. No connections to the higher frequency. A lot of people have trouble conceptualizing this, but if you think about a Yagi antenna, we're all familiar with Yagi antennas with reflectors and directors. Well, they don't have any connections to the other elements either. They accept energy from the driven element and they re-radiate it. Well, this accepts energy on the higher frequency from this antenna, and because it's resonant at the higher frequency, it actually makes this antenna kind of part of the coupling system that couples to it, and it turns out it has a manageable impedance on both frequencies. The other antenna is longer and still operates the way it always did. The higher frequency antenna, just sitting there, radiates on the second frequency. So this is kind of slick, except the idea of having a tube over your antenna hanging between your trees is a little bit off-putting. But
You could use coax though.
you could use coax, but even better, you can use multiple wires to simulate a sleeve. I've shown 2 wires here, half wavelength at the higher frequencies, just sitting there next to the antenna. So all of a sudden, if depending on the spacing and certain other parameters, we have an antenna that has a 50 ohm impedance at the lower frequency, and if we space it right, a 50 ohm impedance on the higher frequency, with no connection between them. Isn't that slick? I was kind of thought that was good. And we could even, as I say, we could even do it at a single frequency. And this was actually patented by a ham, Gary Breed, who's famous for the K9AY loop, a medium frequency receiving loop. He had a patent on this, and he let it expire, which is interesting. And there's actually one manufacturer who's actually manufacturing a Yagi that uses this principle. And what's particularly interesting is somehow he managed to patent that. I don't understand the patent box sometimes. But anyway, so again, we have one wire resonant at a lower frequency connected to a transmission line, another wire resonant at a higher frequency. It's not connected to anything but just sitting there, and all of a sudden we have a 2-band antenna.
What kind of spacing between the two?
Well, I think I have the formula in here at the end. The spacing determines the impedance that you see at the feed point on the higher frequency. So you can adjust the spacing, and it's a function of the element diameters, just like a lot of transmission line kind of equations. So depending on the element diameters and the some other parameters, will determine what spacing you want to use. And it turns out to be very convenient, as I'll discuss in a minute. And you can even have more wires. You can have a 3rd wire that's resonant on a different frequency. Now, how many wires can you start putting around this thing before you can't make them all work anymore? It's kind of a mechanical question. But if you've ever looked at the Force 12 Yagi advertisements, they use this principle and they got a patent on it. Now, how they could get a patent based on the prior art that Gary Breed did is a little bit of a surprise to me, but nonetheless they did that. Sir?
For your purposes, it's easy to put them one on top and one on the bottom, but can you actually put them on the sides?
Sure, doesn't matter. Whatever works for you mechanically.
Okay.
And I'll show you in a minute. My mechanical solution was described in the May 2011 QST. I don't know if you saw it. Called a folded skeleton sleeve. This was kind of an act of desperation on my part. I was given one of those interesting challenges by my boss to come up with a short antenna for a book he was writing. He said, sure, I can do that. And I had all these ideas of antennas I wanted to try developing, and I ran out of them, and none of them worked exactly as well as I thought they would. So what I decided to do was attack this concept, and instead of having this come out the full length, actually bend this around, fold it back around to make it shorter, and then I could say it was a short antenna and a multiband antenna, like that. So it doesn't exactly work that this length folded back is a half wavelength, but there is a length that you can make that's shorter than a half wavelength that actually works. Now what does this look like to you? You read the article.
Looks like a Moxon, distorted Moxon in a way.
Kind of. What I was thinking of was this. This is a piece of 450 ohm window line. So this answers your question about the spacing of the beads. With the wire associated with window line and the dielectric here, it actually comes out a virtually perfect 50 ohm match on 2 bands. And this is the slickest 2-band antenna I've ever come up against. It takes less time to make than it does to talk about it, which is good for my voice is giving out. But it was just a piece of window line with the ends shorted, and a gap here, and these are the dimensions that work on 40 and 20 meters. This is the one that was in the article. And it is a phenomenally easy antenna to make and easy to duplicate, and it's turned out to be a great success. One of the interesting things about it was, I built it and I put it up, and I have these temporary halyards behind the house at about 30 feet. Worked great on 40, fired it up on 20. My first contact was with Australia with it. And the interesting thing is, Bob Allison in the ARRL lab built one and put it up, and his first contact on 20 meters was Australia also. Now, I don't think it's guaranteed to do that, but it's kind of interesting. Anyway, this is the what I first called the folded skeleton sleeve antenna, and I decided later a better, more descriptive name for it is the coupled resonator antenna, which was the words that Gary Breed used when he described his coupling mechanism. So, whatever you like to call it, but that's how you build it, and it works very well. That's it. Let me go back. If you look at this, you might think, well, in fact, let me go back one more. There's another thing, let me go back one more from there. If you had these two antennas, you have two half-wave antennas, there's another way you could make a two-band antenna with this, right? For example, if you cut the higher frequency one in the center and hooked up the two pieces there, you'd have a pair of parallel dipoles, right? So you might say, well, why wouldn't I want to do that? Because I could do that with window line also, right? People have done that. Well, there's a good reason. This actually works better. It's also mechanically superior because the upper piece provides additional mechanical support at the joint, so you don't have the wires pulling at the connections. It's kind of a nice feature. I did mine with window line that had stranded copper weld. So it's basically steel, copper-plated steel. This thing is very strong. In fact, I guess I should say that I put up one. I don't know why I can't talk anymore. My fourth career was as a college. No, third career was as a college teacher. I could talk for 4 hours straight.
Joe, can I get you a glass of water?
That would be great.
It's may take some doing. Oh, you're all set? Thank you.
But anyway, so the other option you would have, thank you very much. The other option you would have is to do parallel dipoles. How many people have tried doing parallel dipoles? I have two. They are a real disaster in my opinion. They are tightly coupled, and if you trim one, it throws the other one off. It's almost impossible to get them to work on more than one band. And people used to talk about using 5-wire rotator cable and making a 5-band antenna. My only explanation for that is they must not have ever measured what it did, because I don't think it's possible to get something like that to work on more than 2 bands at a time. But anyway, let's look at the performance. These are the easy neck plots of the on 20 meters and on 40 meters of the antenna we've just seen. So you can see, no it's not. That's parallel dipoles, close parallel dipoles. That's the hooking them together in the middle. And notice what happens. The higher frequency antenna, SWR, goes up to 2.5 to 1 on 20 meters. So one of the things I've also noticed is when you do parallel dipoles, the bandwidth is less than you'd expect to see. And that's what EasyNet predicts. Here is the folded skeleton sleeve 2-band antenna. EasyNet in the solid lines, the X's actually measured at my house. And as you can see, the bandwidth is much broader on the higher frequency than if you hook them together. So that's a reason for it. Plus, it's much easier to trim them. They're almost independent. In the article, I describe how much they change with each 1/4 inch. And it's not a big problem to trim these without them interacting. So it actually provides improved performance both mechanically and electrically to parallel dipoles. There are two versions of this. One is the folded one, which is not as shortened as you'd think it might be, and it was kind of a force fit to the idea of making a shortened antenna, to be frank, but it seemed good to do. And the other one is the unfolded one, which is just the two parallel dipoles. I've got, I don't know how many emails from people saying, yeah, that's really great, but I want one for 160 and 2 meters. Can you do that? These are the folded ones that I actually modeled. I didn't make all of them. I did make this one, the 17 and 12, I actually have running at my house, and it survived Hurricane Sandy just fine, or whatever, tropical storm Sandy. And I've had them go up as far as 2 meters for the folded one, and for the unfolded one, somebody wanted one for 2 meters and 70 centimeters. And people actually built these things, and they said, oh, it worked great. I did just the measurements that EasyNet predicted, put it up, and it worked just fine. So it's very easy to duplicate and works very well. I mentioned that on the unfolded one, there are two ways to build it. You can either just have the inner part with the two wires be the window line, and then extend the lower frequency one with a piece of copper wire. And then if you just use bare wire, you get a different dielectric constant, and it wants to be a different dimension. I think avoiding the solder connection is worthwhile, and I recommend making them out of window line and just cutting it off and throwing away the other piece of it, just to avoid the connection in the middle, because in my experience, the solder connection in the middle of an antenna is where it will always fail because of fatigue. So that's where it looks like. I would say that if anybody is interested in this, since you probably aren't writing all these numbers down, if you send me an email, I can send you a little brief presentation of the last 4 panels that give you the dimensions for all the bands if you ever want to build it. And if you think of a band combination that's not on there, if you send me an email, chances are I'll send you the dimensions that EasyNet predicts for it. So that's the folded and unfolded skeleton sleeve antenna that was my first experiment in coupled resonator antennas. But of course, once you have an idea that works, you keep going with it, right? The next one started out with the idea that most people are familiar with tri-band trapped Yagis, such as the TA33 is kind of the classic antenna. 20, 15, and 10 meters. The 50s DX band, we didn't have 12, 17, 30 meters back in those days. But now we have a lot of other bands, and one of them that HF transceivers now include often is 6 meters. And a lot of people would like to try that. Well, the tri-band trapped Yagi doesn't usually work. There's a few exceptions, few that actually do by accident work on 6 meters, I've heard, but not very well. So my next project was to use a coupled resonator or skeleton sleeve to add a 6 meter 3-element Yagi to a tri-band. It has a lot of advantages because single transmission line to go around the rotator. Doesn't have any additional height. I started out, yes?
Quick interrupt. Was the traditional tri-band Yagi a TA33?
No. But it was a clone of one. And people have used it on, I've gotten a lot of reports, people use them on a lot of different antennas. This was actually a Wilson tri-bander, which is
The System 3?
Pardon me?
The System 3?
I think so.
Wilson?
Yeah, it's a 3-element, almost the same dimension, same general design as a TA33, split-driven element. That's the one issue. It has to be a split-driven element, any kind of fancy thing. Now, it does work, I found, with a beta match. There's an article coming out in March that has a beta match 10-meter Yagi that it works with. But a gamma match, my modeling says it will not work with a gamma matched Yagi because the higher frequency energy just doesn't get to it, I think. In my case, I really wanted, I had a transceiver that had 6 meters. I had this Yagi I got for $50 from 1975 or something. And rebuilt it, put it up there. And I thought I'd really like to get a 6 meter Yagi also for the 6-meter part of my transceiver. And then I started, my antenna system, my rotating antenna system is on a mast, not a tower. So the rotator is hanging out on the top of the mast. All the wind forces are providing wind loading that's tending to snap the rotator off. I mean, the way to build an antenna system like that is to have the rotator in the mast so that there's a bearing on top that takes those sideways forces. And I think with the one antenna there, I was just about at the limit for 80 miles an hour, I had figured. So I figured, well, maybe I could sneak in a little Moxon or something, the 6-meter Moxon that PAR makes. And I modeled it a couple feet above the tribander, and the performance of both of them was very poor compared to either of them by themselves. So I said, well, that's not going to work. And then this occurred to me. I could try this. And it worked. So what I have is the coupled resonator 6-meter driven element next to the tribander driven element. In my case, it wanted to be 10 inches away to get the right match, and I was up on the roof fooling around just getting it right. A 6-meter reflector and a 6-meter director on the same boom as the 10-meter, or the tri-band antenna. This has a lot of advantages. No additional wind load to speak of, because the 6-meter elements are in the shadow of the tri-band. No additional height, no additional bending moment on the rotator. Single transmission line, single lightning arrestor. It's great. Performance, not quite as good as if it were up there by itself, but you know, 6 meters is 6 meters, and I'd rather, if I'm going to have something up there, I'd rather have the whole bunch than just a 6-meter antenna. So I think it's down at 1.5, 2 dB from a 3-element isolated 6-meter antenna in the same place. But it is so cheap and easy that it's been a real plus. I made it out of fairly fancy pieces, because I was writing an article, the ARRL bought me the pieces, so. But you can make it out of hardware clamps. These are all from DX Engineering. Very nice. I don't know if you ever worked with, this is not a commercial, but I was just very impressed with their element clamps that have these cast members in them. Very easy, if you've ever tried it, when you tighten down a U-bolt on an antenna element to make it into a flat antenna element, and it doesn't have any strength anymore and it breaks. This works very well. All stainless, aluminum from them also. This is a piece of, I never can remember if it's polycarbonate or acrylic, which is the good one.
Polycarbonate's the good stuff.
Okay, polycarbonate, okay. McMaster Car, and I don't think they listed on their webpage, but if you call them, they still have it. They were selling 6-inch by 6-inch pieces of this, 1/4 inch thick, for, I don't know, $5 a piece as a sample kind of thing. 2 pieces like that, cut in half, make enough insulators for 4 elements. So if you get together with a friend, you can save one, because you only need 3. Actually, what you do is the first one you realize how poor your drilling skills are, and then the other 3 you do more carefully, and you make it all fit.
Joel, up in Norwalk, Lorex Plastics, you can get scraps up there periodically.
Oh, yeah. But I was very happy with this, I forget how much it was almost negligible. I mean, you didn't have to buy a giant sheet of it to throw it all away. Anyway, that's the way I put it together. And I chose to do the, you can make elements that contact the boom or insulated from the boom. And either can work, but if you make them insulated from the boom, you can analyze them as if they're not in the presence of the boom. It's kind of a separate thing. And if you make them in contact with the boom, you have to make sure they stay in contact with the boom, otherwise you get noise and stuff. So this was the way I used the insulator. Interestingly, there's an article in the March issue of QST this year coming out of somebody, the technician special, a guy had a 10-meter Yagi with a beta match, which is why I know it works with that, and wanted to try this, and I modeled it for him, and it seemed like it would work. Then for some reason he went and used Cushcraft element clamps that tie directly to the boom. So all of his dimensions are different, and I said, well, you know, if it works, that's fine. Okay, so he's got different dimensions, but it can work either way. I just chose to do it this way. And this is what it looks like on my roof, or above my roof. What's interesting is that you can see a little bit of the yellow paint from the matching the siding that goes up there. That 2-inch steel pipe disappears against the house. I live in a town that does not allow antennas particularly, or I don't think they do, and it's got a real tough building department and so forth, so it's much easier to ask for forgiveness than permission in my experience. So far, I stuck this in, I had just the driven element resting on my top of my chimney for about 2 years to see if anybody would notice. And nobody did. So then I put it up a bit at a time. It looks like it's just a pipe mast tied to the house, and it is, but I give you a caution that I concluded that there, in an 80-mile-an-hour wind, there would be about 300 pounds of force pushing away from the house that was coming that way, and I think that would pull the siding off the house or the house apart. I had one antenna actually pull a window out of my house one day, so I'm a little sensitive to this. So what I've actually got is I've got on the upper bracket, which you can't see on the side of the house, I've got, rather than just having it bolted to the framing members, I've got threaded rod going in. On the inside of the attic, I've got toggles excuse me, with galvanized steel guy wires with turnbuckles tied into the framing members of the house and tightened up so that if it pulls, it won't pull the house apart. It has to tip the whole house over. So far, we've not had a problem. But anyway, and I do have this little 4-element 2-meter thing up there too, just because I couldn't resist. But that's worked out very well too. Not that I get on 6 that often. Here's what the pattern of it looks like on 6 meters from Easy Neck. Notice he has 13 dB of gain, which, as I say, I think that's a little more than you'd get with a 2-element Yagi optimum spaced all up by itself, but it's fine for me. And the azimuth pattern should look something like that. I don't think it does because I'm not sure I have it optimized, but I was not willing to take the K3 up on the roof and use it with beacons to optimize the reflected dimension. SWR looks like that, and it matches the measurements. Now this gets into a topic that you asked about the coupling distance and the impedance. So this shows you what happened. This is for the 1/2-inch tubing. I guess. I guess 3 sizes of tubing: 6/10 of an inch, 5/8, 1/2 inch, and 0.375 inch diameter tubing in the coupled resonator element. And as you space it from the driven element, this is what happens with just the 2 elements. As you change the spacing from 3 inches to 6 inches, the impedance goes from 45 ohms to 113 ohms. It gives you an idea of the range. So it's not real sensitive to that. Again, because the dimensions are larger, the spacing is different than for the wire. Remember the 10-meter, or the tri-bander, I think, is the 0.6 inches diameter in that region. Now what happens is, of course, when you put the other elements in there, the impedance goes down by about a factor of 4. So that's why I ended up with the wider spacing that I employed. Oh, I guess this is something I'd forgotten I had this in here. Well, I thought something I'd really like to do is do something about 75 and 80 meters. That would be a good application for this. As you may know, you had a dipole for 80 meters and made it, tuned it for 3.75 in the center. You have about a 5-to-1 SWR at the band edges, which may or may not be a problem, but it's something you have to deal with in some way. And that's one of the problems with antennas that have to deal with a wide percentage bandwidth. So somebody came up with this. I tried using my twin layer window line technique, and I could not get it to really cover the range. I could get it to have a couple of low SWR points, but not really cover the whole band. It happened that another guy, Ted Armstrong, W6RNC, submitted a QST article on using a coupled resonator as a wideband antenna element, not as a multiband. And his idea was that by separating these further, accepting the higher impedance, and then matching that impedance, he could cover the whole range. And he was successful with it. As I said, this is going to be in March QSD also. So this uses two wires separated by 15 inches in this case. And that gave him an impedance at the center of 112 ohms, which obviously is about a 2-point-something to 1 SWR. But by using a quarter wave of 75 ohm transmission line, he ends up with 50 ohms at the bottom. And this is the SWR he gets across the 3.5 to 4 range. A lot of people have tried doing this in different ways, and there's been a lot of controversy about whether they were actually successful in what they were doing, or they just had a lot of loss in the system that made it look good. I don't believe this has loss. This actually does this if you duplicate that. Now, if you could find 15-inch window line, it would be really easy to make. but it's a little, still compared to two separate antennas and among 4 trees with 2 transmission lines, it's a viable option, and you can do it with PVC pipe as insulators. He proposed doing that. The only other thing I've found that also can do this, we have at W1IW, is a cage array, which is kind of comparable in performance. It's just a wider antenna. It's like this wide, but it has 4 wires on PVC. This does it with 2, so you save 2 wires, and I don't know how many pieces of PVC, depending on how many space you have. Paul, do you have a question?
Could you go back one?
Yeah.
In the matching section, quarter wave at what frequency?
In the middle of the band. Because remember, this is 75 and 80 meters. So the matching section is at the middle of the band, and that's the way it works. And the matching section is built into the model here.
And it doesn't make any difference whether the longer wire is on top or bottom.
Not top or bottom, but it's very important for all these. I should mention, it's very easy to foul this up. It's easy to do it. There are 2 mistakes you can make. One is, and it's particularly if you have a long piece of window line rolling around the backyard while you're building this, it will not work if you reverse, you get one from one and one from the other. It will not work if you feed the high frequency one. You have to feed the low frequency, which is, I was kind of surprised that it somehow didn't seem like that would be the case. And actually, there is a mode that will work that way, but the impedance is way different. It's in the hundreds of ohms. But so you have to make sure you don't, particularly with the folded one with the gap, to make sure the gap is in the the gap is not mixed between the 2 wires, that kind of thing. You have to be fairly careful about that. I noticed as I was trying to. I don't think I actually made that mistake, but I could have easily.
What kind of loss is there between the shorter one and the driven line?
I don't know that there's any loss. I didn't print the azimuth plot. I could, to see how it compares with a separate one for each.
Sure.
But at least on the 40-20 and the other ones I did, there's really no difference. Yeah, it's free. I mean, it's really free. Now, I have to say, as you'll read in the article, he did not actually build this antenna, which I kept pulling my hair out. I worked with this guy for about a year on this. What he did do, he didn't have enough room for it. So he built all kinds of other antennas like this. He built a dual monopole there's a picture in the article. He built some horizontal antennas at higher frequency, like over 12 to 10 meters kind of thing, that sort of thing. He built enough of them that made me believe it was going to work. Besides, I knew the concept of the coupled resonator worked. And the thing I missed in trying to do it with window line is expanding the spacing to a much wider spacing. So I think it's a real player for this thing. If you do 75 and 80 meters, it's always going to because they're both pretty big antennas if you do two separate. I guess that's the end of this thing. I'm not a word from your sponsor. These are my books, some of my books, if you're interested. And interestingly, none of them talk about this. Because I've written, I think I mentioned it in basic antennas. That was kind of the sequence of them. I also did this ham speak thing, which you probably don't want to bother with. But these are pretty good. And there's another one coming out early this year, I think. Understanding and using your antenna analyzer. But basic antennas talks about this, but it didn't really talk about things you can do with it. It just talked about the fact that there was such a thing. And, anyway, because I guess I got into this after that was all written, is what happened. That always happens to me.
All right, so these are tuned antennas. What if you're gonna use a tuner with it?
Well, that's a good question. And if you're going to use a tuner with it, why I should back up to the very beginning of this thing. Let's see if we can do that in some clever way. My original concept was, or charge, was to build an antenna that was compact, that you could throw in the back of the car and hook to your radio and, do your
Right.
thing. So it's coax fed, and in place of a single band antenna, it works on two. Now, if you have a wide range tuner, and you're willing to feed your antenna with window line the whole way, as I am, I have a 80 meter antenna fed with window line. Paul has one, they work very well. You don't need to fool around with this. You get 6 bands or 7 bands or 8 bands or 9, however many bands you want, you get just by changing your tuner.
Right.
But that's, kind of a different environment. And that's a very good environment. The advantage of this, if it's an advantage to you, is that you get dipole patterns on both bands. If you have an antenna that you feed with a tuner, you get half-wave resonance and half-wave pattern in one band, full wave and 2 wavelengths, and you get all these different patterns. And that can be very good because, and I used to have them all plotted out before I got this Yagi. And if I wanted to work a D-expedition, I'd see on which band he was in the null of my pattern, and I wouldn't bother to try to work him on that band. I'd wait till he's on another band. So, it's got a frequency agile directional antenna kind of thing. You just have to hope it all works. With this, you can have very predictable dipole patterns on 2 bands, and they can be quite far apart bands too. So it's a whole different thing. This is for a coax-fed antenna that you don't need a tuner for, and you do the tuning with wire cutters first, and then you don't have to worry about tuning your tuner.
Now you're using ferrite beads. What about just loops for the coax?
That works very well too. The one thing about, actually, in general, that works better. Why is that? If you use a ferrite toroid with multiple turns, the inductance, the choking impedance, goes up with the square of the number of turns, okay, because they're coupled. This goes up with the first power of the number of beads. Each one of these is 1 turn, so they're just 1 turn inductors in series. So for the same number of turns in the toroid, you get the second power of inductance. You get higher inductance. This is, in many cases, well, this is the only way to do it, in my opinion, with foam coax. Because if you take foam coax, you pull it through the toroid, what happens is the center conductor migrates on the bends. It's not designed for that sharp bend radius. The center conductor migrates through, and in the worst case, you can short coax out, which is not a good thing, which doesn't happen here. This is also a little easier mechanically, I think, to just, it depends. If it's polyethylene, solid polyethylene, coax, there's nothing wrong with a ferrite toroid and a lot of turns. I think it's a little heavier, and it probably takes a little more coax, which is a little heavier, and that pulls things down, and, you know. But this works very well on higher HF bands, I think. Other questions, Fred?
I just wanted one comment. If anybody models this on EasyNet, there are certain rules you got to be really careful about when you have close
Absolutely right.
conductors. You get fooled because I had some years ago discovered this phenomena, and I thought I had something really great until I realized that I had something where the antenna was radiating more power than I was putting in.
And that's really good. And this one does not do that. You don't get
Very
it.
effective.
You have to make sure that you line up all your segments on
That's
each
right.
thing.
And you have to have a lot of segments. That's a good point. Does anybody do EasyNet? And if anybody
Sounds
wants
right.
one of these models, I'm happy to send you. I got a gazillion of them. Just to reiterate what Fred said, the way EasyNet works is you put in the wire, you put in the dimensions of the position of the wire from here to here is the XYZ coordinates, and then you say, I want the analysis to happen as if this were a bunch of little wire segments, and it adds up the effect at the far field. You don't have to worry about how it does it, you just have to pick a number of segments, and if you pick the wrong number, it'll tell you, you need more segments, or you have too many segments. But, so you have a wide variety of what you can put in, and it doesn't notice the fact that you have this coupled wire there when it's doing these checks. So not only do you have to have them the same length, you have to have them in alignment with each other. You can't have segments offset because the coupling doesn't get modeled properly. And that's tricky with this. It took me a while to figure out how to do this. Because at first I was saying, well, I've got this distance and that distance in there. I've got to have these segments in here the same length. So every time I changed the length, I had to go through and pull my hair out, and you see it's just a little left here. I'd have to recalculate the number of segments. I was getting gazillions of segments to make them come out even. And then it occurred to me, I don't have to do that. I can have this inner part, the two wires in the inner part, just stop here as far as EasyNet is concerned. Have another wire start here, have one segment, and then have these wires together. Then I just adjusted them together, and it made them, it had the same number of segments in each of these three regions, and then I could adjust them together without having to make myself crazy trying to keep them in alignment. I don't know if that made any sense to anybody, but that's how you model this with EasyNet. You cannot do this with the free version of EasyNet that has 25 segments. The way you tell if you have enough segments, one way is to double the segments and see if the answer changes. And if it doesn't, you can say you were pretty good where you were. The 25 segment version will not hack it. I think I was just discussing this with somebody who's been giving me a hard time about the modeling, and I noticed that I had something like 1,000 segments in one of these very small segments because of the close proximity. You have to do a lot of calculation. Your computer is going to work hard. Fortunately, they don't take a lot of electricity, and they just do it while you go get a cup of coffee or something. But it does take a lot of segments, so the 25 segment limit is going to keep you from doing this on the free version. Maybe you could try it on a very small scale. I don't know.
There are other programs like
Yes.
MMA and I
There are a whole bunch out there. Some of them are free.
yes.
Now, I started EasyNet back when it was
In
on
DOS.
DOS 3, and I have not, I tried one of the other ones. Somebody was complaining that I always talked about EasyNet, and well, it's the one I know how to work, and I tried doing another one. I didn't like it. But that doesn't mean you shouldn't do it. They're all, most of them use the NEC computational engine. They're all front ends to that. So if they translate the information properly, they should all give the same answers. So if you start out with a free one, learn how to use it, maybe you'll be happy with that and not have to worry about sending Roy Llewellyn $100 every
150 or so.
whatever it is that keeps going up.
So Joel, I'm just curious, what town do you live in?
I live in Westport.
Oh, Westport. Okay.
Well, I don't know how much time we have here. I can talk, almost talk forever, but you probably want to do the rest of your meeting. Unless there are any other questions, I can fold my tent if that's it. And as I said, please feel free to send me an email if you want the dimensions for all those coupled.
You already give your emails, hopefully they'll remember it.
No, it's an unlisted email. No. W1ZR@ARRL.org.
Just a quick question then, as long as you're willing to go afield. You ever done a bobtail curtain?
I'm familiar with it. I don't think I've ever actually built one. That's basically a 3-element vertical array fed from the center, the bottom of the center element, and very easy to implement. And it gives, the current divides, so it actually gives a binomial current distribution, which is something I discuss in my book, I think. The current in the center is twice as high as the current in either of the outside of it. It's just a wire across the top, and then 3 wires hanging down, and it has a nice broadside pattern to it. Anything else? Okay, well, I'll go back to that last one that said thank you for your attention. And I'm going to shut this thing down. Let's not go over.
That wouldn't be bad if it were a powerboat.
It's got a power, it's a tugboat and drag. I updated the, I've got a three times the power, it's got a Yanmar diesel, it originally came with a 6 horsepower, 1-lunger. It's now got a 15 horsepower, 2-cylinder, freshwater cooled diesel and a 3-bladed prop. And so it can be a powerboat too. And I get about 25 miles to the gallon on diesel, which is not too bad.
I used to use dipoles up over the bridge from stern to bow.
Yeah.
Power. I used hustlers, and I used all, and I had a 10 meter or an 11 meter whip on the boat. When I bought the boat, it had 11 meters on it. I used that for everything through 80 meters with a tuner. And with the ground system on the boat, worked like gangbusters.
It does. I have an insulated backstay, which gives me about a 30-some-odd foot
Right.
vertical fed against basically the engine block. I was going to put a great ground system along the inside of the hull.
I started out with tubes in the bottom, but I went to that Dyna ground.
I didn't even bother with that. I thought about it. I used to do marine VHF or HF radios, MF radios back in the early 60s. And they had all these fancy ground systems, which were great. And I got out there. I'm a member of the Antique Wireless Association. They have a net run out of Rochester every Sunday afternoon
Right.
at 75 meter AM. And with 25 watts of AM from my 706, and that antenna with just using the engine block and the negative wiring in the hull as the ground system, I got into the net with as good a report as I got from home from my Viking 2 with a big antenna. I said, 80 meters is going to be the worst band for ground to make a difference. If I can do that, I'm going to stop now. I don't need to do it anymore. And I haven't done anything since. But a good ground would be even better.
Yeah.
I don't know if you know Rich Rosler. He goes sailing with me a lot, and he keeps wanting to do more ground stuff and throwing things over the side and whatnot.
Well, I was up in Mystic one time, and at the dock,